Okay, do you remember your white blood cells? Which one of these is not a macrophage? Natural killer cell, neutrophil, eosinophil, basophil, or none of the above are macrophages? What do you say? Yeah, natural killer cells. They instead look for things, look for bad guys that are handcuffed by an antibody. Then they release the perforins and the granzymes and cause it to kill itself. All right, so second line of defense, we looked at the antimicrobial proteins, we looked at antimicrobial cells, we looked at fever. So now we're down to that last thing, inflammation. Inflammation is a non-specific local defensive response to tissue damage, all right? So anywhere in your body where you damage tissue, you're going to get inflammation. It's a common response to most disease states. So again, these days it seems like inflammation is a dirty word. Yeah, inflammation out of control is definitely a dirty word, but inflammation is normally a good thing. You want inflammation that's helping you get better, all right? It's a natural response to most disease states. What's the purpose of inflammation? We've talked about this a few times, really. Disposes of pathogens and dead cells and debris. Helps prevent the spread of infection, all right, by bringing more white blood cells to the area. Prepares the site for tissue repair, more nutrients, all right, in order to fix whatever was damaged. And it's regulated by cytokines. Once again, all those interleukins. And there you see in the lower right here, feel better with flamies. I don't know what flamies is, but man, if it makes you feel like that, I want to get some flamies. I want to feel like throwing my arms out like that and walking through a field of wheat or whatever that is and looking up at the sky and just feeling awesome like she apparently is. Man, I'll tell you, everybody on the planet should be taking flamies if it makes you feel like that. That's so awesome. I'm going to look for that the next time I go to the store. Here, just to try to show you all the things involved here. Oh my God, look at all what's going on here. Agents of inflammation. Look at all the things involved in the inflammatory response. A lot of these we've talked about, so I'm not going to say you have to know every single thing on this chart, but this is a good summary. I would look it over. And, some of the things we like bradykinin, I didn't ever talk about those. But other things on here we have talked about. So a nice kind of a review slide to go back over. And at least for the things we have covered and you do know about, a good slide to just refresh your memory, remind yourself of what's going on. So let's look at the inflammatory process. Ooh, there's some gnarly inflammation there, isn't that? So mast cells, basophils, damaged cells secrete vasoactive chemicals, such as histamine. Histamine is a vasodilator. So it opens up those blood vessels and brings more blood to the area. Kinins. So kinins as well are involved in producing the inflammatory response. Leukotrienes, I'm not going to go into any details about these. Those are all on that slide we just looked at, okay? So you can look back there. I did mention kinins before, like wasp venom has kinins in them. They're involved in causing both pain and inflammation. So leukotrienes we're going to see coming up again. This isn't the last time we're going to see leukotrienes. I'm going to save them and talk about them more when we see them again. Local vasodilation of blood vessels. That, of course, is going to bring heat to the area, isn't it? All right, and it's going to make it warmer. Because remember, your normal surface body temperature is around 37, but your blood's at around 38. So when you bring more blood to the area, so the area that's inflamed is going to be somewhat warm to the touch. You're going to have erythema, which is redness, because there's all that blood there now. See, look at those person's fingers. See, that's erythema. You're also going to have, because local increased capillary permeability, when you vasodilate, those junctions, those endothelial junctions are going to open up. So you're going to get more permeability, so more stuff is going to leak out. Therefore, you're going to get edema. More blood plasma is going to leak out. That means edema will always be there. And when you get edema, you're going to start pressing on nociceptors, pain receptors, and that's going to be painful. So these are called, by the way, the 4 cardinal signs of inflammation: heat, erythema, edema, and pain. Those always accompany inflammation. There's sometimes a 5th one called loss of function, which generally means, look, if your knuckles are swollen up like that, you're not going to be able to use your hand in a normal way. So loss of function is the 5th one. Every medical student knows, they use the old-fashioned words. Every medical student would know calor, rubor, tumor, and dolor. Latin root words standing for heat, erythema, edema, and pain. But I do want you to know, I absolutely want you to know the 4 cardinal signs of inflammation. And a lot of books now have the 5th one, which is loss of function. You should probably know that too. But certainly heat, erythema, edema, and pain, and know why. All right? So it all has to do with the heat and the erythema, because more blood's coming there, and then the edema and the pain are because of the increased permeability. You should know that. You should know all about inflammation. And there you go. Here we see margination, by the way. So here we see neutrophils in this case. Margination is where they basically stick to the endothelial wall. They're little surface markers that work kind of like Velcro. So what they can do is they kind of like roll along the inside of the endothelial wall until they find a cell junction, all right, where there's a little bit of a gap. And in the case of inflammation, the gap will be bigger. You have increased permeability. So that neutrophil in this case is going to squeeze out. So margination is where it's rolling along the inside of the blood vessel. And it uses what are called selectants and integrants. Those are like the Velcro. All right, I forget which one is on which. I've looked it up at least 70 times, and I can never remember. One of them is on the white blood cell. The other one's on the cell wall. And every time I do this class, in the classroom, some student immediately Googles it and then tells me just to humiliate me in front of the class. And that's fine. It's payback. I humiliate my students all the time. It's always fair to humiliate me as well. Then diapedesis, we mentioned this before. That's where they squeeze out, all right? Then chemotaxis, all right? They sniff out the chemicals that are being released by the bad guys. And then phagocytosis. There you see, look at that neutrophil eating up bad guys, all right? See? This is why inflammation is good. See, somebody got a splinter in their skin, and you see the inflammation, all right? And then what's going to happen is pus forms. Pus is not as gross as you think it is. Pus is basically just dead bacteria and dead white blood cells. That's all it is. That's why it's white. And then who's going to clean up the mess? Yeah, macrophages. They're going to come along and eat all the dead bodies and eat up all the pus and all that kind of stuff. And there you go. Nice, beautiful diagram showing everything, illustration, showing all the stuff we just talked about. Look at all the stuff there. There's inflammation, all the parts. Be worthwhile to spend a few minutes going over that. Just, learn. Have it, really get embedded into your head. That's the way learning works. Really, you just kind of sit down and you just decide, set a timer. You got your damn cell phone. Set a timer for, let's say 7 minutes. And just spend the next 7 minutes looking at that diagram. There you go. Heat, redness, pain, swelling, possible limitation of joint movement. Just look it over. I mean, come on. You got 7 minutes. Do it. It'll help. All right, which statement is false? All lymph ultimately drains into the blood. Both lymphatic vessels and veins have valves. Natural killer cells are part of the second line of defense. Monocytes leave the blood via diapedesis. Fever, erythema, edema, and pain are the 4 cardinal signs of inflammation. 4 of those are true. 1 of those is false. Which one is false? Did you get fooled? It's not fever, it's heat. Fever is systemic. That's your whole body. Heat from inflammation is local. It's only where there's the extra blood cells.